Good morning, everyone. First thing first, thank you for joining this session by taking your time out from your regular activities or daily job. This is our title today, Introduction to Blockchain and how it impacts various industries. And so agenda of today's session will be, first we will see some introduction to blockchain, what is blockchain is all about, what are the key components of blockchain and how it works. And then we will move on to the benefits of blockchain and then we will see how it impacts the digital evolution era. Everyone knows that we are living in a digital evolution era. Like if something we need to buy something from the grocery stores or vegetable stores, we our mom will send us to the shop. நம்ம போவோம் போய் we will buy things and then மிச்ச காசை கமிஷனாக நம்ம எடுத்துப்போம். இப்போ அப்படி இல்லை. Like we can also buy everything in online. It's all digitalized. In a WhatsApp group, someone from our office ordered a chips packet in Zepto and it got delivered in 12 minutes. So commission earning within the family, we are also giving commission to the other party. So that's how the digital evolution era. We also had some interesting sessions on second brain, digital lending and digital marketing previously. So everything is digitalized now. So we will see how blockchain impacts this digital evolution era. And we will see the blockchain impact on industries. What are the challenges and concerns we have based on because of this blockchain technology and where this blockchain technology can be applied and a couple of real world examples which I came across. And then at last we will see how blockchain can impact trade finance. Trade finance is one of the mainstream which I worked for long years. So by seeing the benefits and challenges and concerns of blockchain, we will relate how it can impact the trade finance processes. And we also see one real world implementation of blockchain in trade finance process. So moving on to the topic, the first one is what is blockchain? So a blockchain is a decentralized, distributed, and public digital ledger that is used to record transaction across many computers so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the consensus of network. So பெரிய definition சொல்லிட்டேன்னு don't worry. So that's why I split it into different points. So it is a distributed ledger. So the record of transaction is distributed across all nodes in the network, and it is also decentralized, which means anyone in the network can participate, see the records. So since anyone in the network can participate and see the records, it also promotes the transparency and everyone in the network should give the consent mechanism, and it is very difficult to alter the data in the block. So we will see all this in bit in detail in the next slides. So this is the basic definition of blockchain. So to keep it simple, it is like our Google spreadsheet where we store it in our shared drive, where many users can work at the same time and stored in a cloud database. But blockchain it is not stored in the cloud database. It is stored in many computers across the networks after the validation. So anybody can see the data, but no one can corrupt the data. So since everyone in the network has the data, have their own data of the blockchain, it is bit tricky to corrupt the data. Moving to the next one, what are the key components of blockchain? So key components of blockchains are blocks, cryptographic hash, chain, and distributed ledger. The block is the main component where the data are stored. So data can be anything. It can be transaction, it can be some details about the goods, some details about the supply chain, or some details about the patient. So it depends on the industry where we're using this technology. So the block is just a data. Well, just like a container where the data are stored. And next one is cryptographic hash. So cryptographic hash is the data, we will encrypt it and we will convert into a hash. And how we are going to convert into hash, we will see a short demo. The created hash is a unique identifier for each block. It is similar to the fingerprint, our fingerprint, like how we use Aadhaar card with a fingerprint. Once we give a fingerprint, all the data of our Aadhaar card can be seen. Cryptographic hash is like a fingerprint, digital fingerprint for a block. And the next one is chain. The chain ensures the chronological order of transactions. It is where the each and block is connected. And how it is connected? It is connected with the help of hash. And it is also a distributed ledger where the records of all data is shared across the network. Now we will see how the blockchain works. So let us consider there is a block. And in a block, there will be a data. The data is encrypted and converted into hash. and we also have previous hash. Data, like I mentioned before, data can be anything. For example, if you take a Bitcoin, Bitcoin is a cryptocurrency which uses the blockchain technology. For Bitcoin, the data can be like a sender, receiver, amount of transaction between the sender and receiver, and it can also be the balance of both sender and receiver. The hash is a digital fingerprint where the data is converted into encrypted and converted into 64 hexadecimal numbers. And previous hash is the hash of previous block. It is also a main key component in the block because it is used to link the previous block to this block. So data, we know it is simple, and we will move to the cryptographic hash function is where if you input any data, it will create a fixed size string of characters from any input data. It is like a unique identifier for each block, like a digital fingerprint. And there are many hash functions available to encrypt the data and create a unique identifier. The Bitcoin uses SHA-256 hash function. The SHA-256 is which will convert the input into a 64-digit hexadecimal function. So there is a link online where you can see how the data is converted into input data is converted into a hash. So we will see a short demo. So like I mentioned, there are various cryptographic hash function market. So here you can input any data and you can see how it is converted into a hash 64 digit hexadecimal hash. So any data you enter, it will show the fixed 64 characters, numbers and characters, hexadecimal characters. Why it is hexadecimal? You can see I just entered AX. So it will show some set of numbers and alphabets. This is called hexadecimal characters. Hexadecimal is nothing but the numbers 0 to 9, and hexadecimal is consists of 16 numbers. So since we cannot have 16 after 9, you cannot have 10 or 11 or 12. It will show A, B, C, D, and E. So if you see in this, you cannot find any alphabet after E. So now I just entered X and it showed me it converted the X encrypted into a 64 hexadecimal characters. Now let's see, your data is X pay by $50. So once you enter the data, you can see it is converted, the dash is changing. Even one small change in the input data, it will totally change the hash. For example, let's say when I change from 50 to 100, you can see the hash is changed completely. It can be any data. It is not only the transaction, you can enter any data.
Prasanna, can you the same X space Y $50 now? Will the
Yes.
hash be the same? What it
Yes,
was
yes, it
earlier?
will be the same. For the same data, it will be always the same. It will always give you the same hash. If you see here for X space $550, it starts with 1198F9 and ends with 77E.
So,
When I
so
change to
if for
100,
okay, you
okay, when I change to 100, then the complete hash is changed now. But when I switch back to 50, it is still the same hash, 1198F and 77E.
so is it not possible? Is it possible to reverse and find the data from the hash?
It is possible. So that's why blockchain technology has various other mechanism where the data cannot be tampered. So we will look into that. What are the other mechanism the blockchain technology has?
Okay.
Okay, so this is a short demo on how the input data is converted into hash. We'll move on to the presentation. So now we will take an example. So consider we have a three blocks linked to each other. So each and every block has the hash and also the previous hash. So if you notice here, the third block's previous hash points to the second block hash, and second block previous hash points to the first block hash. So this is how the blocks are linked together, the previous hash and the hash. Now let's see the hash of first block. It is all 0 because since it is a first block, it is a bit special as it cannot point to any previous block. So in blockchain technology, it is called genesis block. Now let's consider some hacker is trying to tamper with your second block, like how Balaji asked. He tried to change S space $50 to S space $100. So then what will happen? This will change the hash of the second block. So from 5 BBM, it will change to B6Q1. So now when the third block previous hash and second block hash is not seen, the linkage between the blocks will get disconnected. And we don't have a valid genesis block 2 since the first block doesn't have a previous hash as 000. We think, wow, what a way to prevent hacker from tampering our data. It is so secured, but not. Hackers and computers are so advanced nowadays, like how Balaji has. They can easily guess the data based on the hash because hash function will always use same hash for the particular input. So they can easily recalculate, tamper the data, and recalculate the hash of all the blocks available in the chain. Only hackers need to spend little time to recalculate all the hashes. So to mitigate this, blockchain have something called consensus mechanism. There are few consensus mechanism available for the blockchain technologies. We will see a couple of them here. The first one is proof of work. Proof of work, it was first used by the cryptocurrency Bitcoin. It is a mechanism that slows down the creation of the new blocks. How it slows down the creation of the new block? All the participants in the network, they are called as nodes or also known as miners. They compete to solve a complex mathematical problem. The first miner to solve the problem broadcasts the solution, and the block of transaction and also the block of transaction is added to the network. Example, for mining a problem for Bitcoin, it will take average around 10 minutes. So consider this. Let's say some hacker tamper any data in a block. So now we want to wait for 10 minutes minus to solve the complex mathematical problem and add the block to the blockchain. Now let's say there is a hundreds of block in the blockchain. So imagine how long you need to wait to recalculate all the hashes and someone to solve the mathematical problem and add the blocks to the chain. So when you think complex mathematical problem, don't think when you say complex mathematical problem, don't think it is like our max 2 or max 3 paper in the engineering. I heard a lot of my friends say, I'm not an engineering person, but I heard a lot of my friends saying max 2 and max 3 are very difficult in the engineering. It is like they will give you a target hash, and there are also a lot of hardware available to mine the target hash. So for example, let's say this is the target hash the miners need to find out. So they need to find out the hash with so many zeros and 16th character as 5. So they will use a lot of guesses, and they will try to solve the data to reach this hash, target hash. And this target hash is not exactly the same like the hash which we generated based on input data. It is just a target hash. To compute this target hash, they need to use so many guesses, like millions and millions of times of guesses. So which that is why it is taking a lot of times. The computer can do millions of problems per second, but again it will take average of 10 minutes to find this target hash. If you see if this is the target hash, if your solution is 3 here, then it is not matching with the target hash because here it is 0 and 3, so this is disqualified. Now when you reach 0 here and it says D here, your expected output should be 5. So the D, which represents 14 in the hexadecimal digit, which is higher than the 5, so this is also disqualified. So it should be always the target hash or less than the target hash. So here it says 5 and here it says 4, so this is a viable solution for the target hash. So this is how the target hash will be used to solve the complex mathematical problems, and the blocks will be added to the network. And there is one more consensus mechanism, which is proof of stake. Sorry, I forgot to mention one point. So what miners will earn by doing this, by solving these complex mathematical problems, they will earn the incentives as Bitcoin. So in 2009, when the Bitcoin was first introduced, it was 50 Bitcoin. So in 2009, when Bitcoin was first introduced, it was 50 Bitcoins for each problem you solved and each block you added to the network. Now currently it is 6.25 Bitcoins per block mining. So one Bitcoin is around 43k USD, and imagine how much one can earn by doing. So next consensus mechanism we're going to see is proof of stake. The proof of stake is evolved from proof of work, but it's slightly different. Here the validators are chosen to create new blocks. How the validators are chosen? It can be any method, any random selection, or you can ask the validators to stake some amount of cryptocurrency to participate in the mining or verifying the data of the block. What validators will do? They will stake some cryptocurrency and they will validate the blocks and create the blocks and add the blocks to the blockchain. And what validators will learn? They will be rewarded with the transaction fees or additional cryptocurrency along with the cryptocurrency which they staked. So this is a new method developed by Ethereum, which is a competitor to Bitcoin. It is also a cryptocurrency. So initially Ethereum used the proof of work, then they evolved and used this proof of stake in Ethereum 2.0. Why they evolved from proof of work to proof of stake? Because proof of work uses a lot of energy to solve the complex problems, and it also needs computers, and it also needs some high-ended hardwares and softwares to compute the target hash. So this is proof of stake. We have this hash, encrypted hash. So it is a little bit difficult for Asher to guess it. Now we have the consensus mechanism. Only these both are enough to secure your data? No. Here, after using the proof of work and proof of stake, what will happen? The validators or miners, they will just add the block to the network. So once it is added, it is distributed to all the participants in the network. The participants, we call them as nodes. The participants in the network, we call them as nodes. So it is distributed among all the nodes in the network. Even the proof of stake, it is also distributed. So once it is distributed, all the nodes in the network verify the block. So this is how it is distributed. Each and every nodes will have their own computer or system where they can see the block data. They will verify the block and they will reach a consensus. Consensus is everyone verify the data and say they will check it and they will verify that and validate the block. Okay, this is the valid data. It is not tampered. It is not a fake data. So like that, they will come to a consensus. Once more than 50% of the nodes provide the consensus after verifying the block, then only the block will be added to the blockchain by linking the previous hash in the chain. So now there is another consensus mechanism called practical Byzantine fault tolerance. This we don't need to mine in this mechanism. We don't need validators. We just need the participants available in the nodes to validate the transaction. This is more suitable for private blockchains where only the private group of participants allowed view the data or verify the data. So transactions are finalized when a two-thirds of majority of nodes reach a consensus. It is energy efficient and transaction finality and low reward variance. It also have low reward because only selected or private group of participants will allow to verify the blocks. So this is the process flow of blockchain. So there is a initiation where user initiate the transaction with data and nodes in the network just verify the validity of transaction like checking the digital signature, the data integrity, and then it will be stored in the in mempool. Mempool is like a temporary pool where the validated transactions are stored, and from there it will move to a consensus mechanism where the nodes in the network, the miners or validators, they will solve the problems or validate the data, verify the data, and come to a consensus. Coming to the consensus, the block will be created along with the cryptographic hash. This particular hash of one block, it will become a part of the next block in the chain. So now after creating the block, and if everyone is agreed to link the block, the blocks will be linked using the previous hash in the chain, and then the updated blockchain is propagated to all the nodes in the network. So all the participants in the network will have the same data. So now, after seeing this process flow, we can assume that to successfully tamper a blockchain, hacker need to tamper with all the blocks in the chain, redo the consensus mechanism, and also need to have a control of 50% of participants in the peer-to-peer network. Now, this is to be a very complex activity for hackers, right? From this, we will move to the benefits of blockchain. So what are the benefits of blockchain? By seeing the process and how it works, the number one benefits of blockchain is security. Here, the cryptography hash, it will ensure the data confidentiality, and the consensus mechanism will ensure that there is no malicious activities. And it is also a decentralized process, which means there is no central authority. There is no single server or single point of hard drive or server where the data are stored, the blockchains are stored. This will enhance the resilience. If something, unfortunately, something happened to the server and all the data is lost, if there is a single server, it's hard to recover the data. But since it is decentralization, every nodes in the network can have the same data. It is very easy to recover, and it also provides transparency, which again related to decentralization. Since it is decentralized and everyone in the network has access to the data, it will provide you a transparency, so anyone can see the data and verify the data. And it also increases the speed by reducing the delays associated with traditional systems, especially in cross payment systems, cross-border payments. The cross-border payments, it's a transaction where you will make payment to one party to another party who living in different countries. There are a lot of disadvantages in cross-border transactions in traditional systems, like the payments getting delayed because of the different time zone. There are a lot of intermediary banks, and any incorrect processing or information needed, they need to follow to all the intermediary banks and the originating bank. So there are a lot of delays, and this blockchain technology will reduce the delays and increase the speed. And we also have the data integrity. Data integrity is reliable and auditable records of transaction. This is the reason why it is immutability. No one can tamper the data that easily. And also it is easily auditable because we have all the previous data linked together, so the auditors can easily audit the data. And traceability. It is easy to trace. Like I mentioned earlier, it is all the data are linked. If something you want to trace in the blogs, you can easily trace because each and every transaction is recorded and linked to the previous one. So any technology or product, along with benefits, will also have its own challenges and concerns. Now we will see the challenges and concerns. So that this is the reason why the technology keeps on evolving with the help of research and development. For example, let's take the evolution of music system. When I used to be young, we have these cassettes and a tape recorder where we insert the cassettes and we will listen to the music. Sometimes the films in the cassettes will get stuck in the tape recorder. We need to do some minor repair by ourselves to make the tape recorder and cassette to work. Then from there we evolved and started to use Walkman, and then Walkman become very small, and we started to use iPod, and from iPod we started to get the songs online from the iTunes, and now we have this online music streaming app like Spotify, Wink Music, everything. After so many evolution in the music system, my 3 years old daughter, she's complaining about Spotify. Why net is required to stream the music online? So she has a lot of complaints about the Spotify. இதுக்கப்புறம் எப்படி எவால்வ் ஆகும் தெரியல. மேபி பிரெயின்ல நினைச்சாவே நம்மளுக்கு சாங்ஸ் கேட்குமோ என்னமோ தெரியல. It is also possible. There is a continuous evolution in the technology to reduce the challenges and concerns of each and every technology. So we will see the challenges and concerns of blockchain. The first challenge and concerns we are looking into is complexity. Being a sophisticated technology, it is very difficult to understand the blockchain technology and implement it. And the next challenge we face is regulation. The legal environment surrounding the blockchain is still developing. Not all countries accept the blockchain technology or cryptocurrency. For example, in India, we cannot do transaction. We can do transaction using cryptocurrency, but it is not legalized. So any dispute raised by using payment made by using cryptocurrency like Bitcoins or Ethereum, there is no proper regulations. Scalability. We are talking about 3 blockchains, hundreds blockchains, but there can be a lot of blockchains with lot of data. So when the transaction volume increases, there can be a scalability issue. The workload increases. And next one is energy consumption. Any blockchain technology implementation which uses the proof of work, for example, proof of work as consensus mechanism, it consumes a lot of energy like computer, electricity, hardware, softwares, and also it provides a lot of waste, hardware waste. So these are the challenges and concerns. The next we will move on the applications of blockchain technologies in few industries. It is well known that blockchain technology is used in cryptocurrencies like Bitcoin, Ethereum. It is a secure way to manage the digital currencies with the help of peer-to-peer transactions without need of intermediaries. Another industry where the blockchain technology is used is supply chain management. The blockchain technology will provide end-to-end visibility and traceability if it is applied to supply chain management. Can be also used in healthcare data management, where we can store and manage the healthcare records and patient records, and the patients can control the health information along with privacy. It is even easy for the healthcare consultant or healthcare professional to trace the patient's data if patients agree to share the data with the healthcare professionals. And next one is cross-border payments, like we discussed earlier. It will enhance the cross-border payments by making faster, cost-effective payments by eliminating intermediary banks and also the different type zones issue. Intellectual property protection. Blockchain can be used to timestamp and authenticate intellectual property, such as patent, copyrights, and trademarks. We all know there is a lot of issues in parallelism in film industry where suddenly all of a sudden one person will come, I'm a blooming director, and this renowned director took the copy of my story and directed a film. So blockchain will help to avoid that because it timestamp. It is difficult to tamper the patent or copyrights or trademarks, and it will avoid the plagiarism. And the next one is decentralized finance. This is the latest term used in the blockchain technology. It is still in a newborn child. It is in the infant stage, decentralized finance. What is decentralized finance? It provides financial service such as lending, borrowing, and trading without traditional intermediaries like banks and financial institutions. So like our blockchain technology, the data is stored in the public domain. All the participants can view the data. This peer-to-peer financial service uses the lending using cryptocurrencies. Primarily, Ethereum uses this. And since it is a global network, the lender and borrower, they can mention the terms and conditions in the application, the decentralized finance application. And once the terms and conditions are met, the borrower will provide the cryptocurrency to the lender will provide the cryptocurrency to the borrower. Sorry. Since it is a global network, it is possible to lend or borrow anywhere from the world. So this is decentralized finance where the blockchain technology can be used. Now let's see some real world examples or implementation of blockchain technology in a couple of industries. So one is supply chain management. First, I will decide what is the huge problem in the supply chain management of perishable foods. It is very complicated since it is perishable foods. There is a high risk. The supply chain management should be very fast and very transparent. Roughly around 1.3 billion tons of food is wasted or lost each year to inefficiency of supply chain, like how it is shipped, stored, and sold. So then the IBM Food Plus comes into play. It was first conceptualized in 2017 using one of the largest non-crypto blockchain in the world, which is IBM, which is not related to cryptocurrency. It is from the farmer, processor, retailer to the consumer. The IBM Food Plus uses trust to build transparency. The solution which IBM Food Plus provides authorized users with immediate access to actionable food supply chain data from farm to store, ultimately to the consumer. The complete history and current location of any food item, along with its accompanying information like certification, test data, temperature data, can be readily available in seconds by using the blockchain technologies and the data stored in the blockchain. Few companies are already using this IBM Food Trust. Some of the major companies are Walmart, Nestle. Another real world example is in healthcare data management. There's a company called Medical Chain, which has an application called White Paper 2.0. The White Paper conceptualized in 2016. What does it do? It uses blockchain technology to create a user-focused electronic health record while maintaining a single true version of the user's data. So it gives user to give healthcare professionals access to their personal health data, and it also provides a band to the users. So any interaction between the healthcare professionals and patients are recorded and encrypted and stored in the blockchain and, distributed to the participants. Obviously, the patients has the control to give access to the participants who can view their health records. And this emergency band, it will be useful in the emergency situation where the patients become unconscious suddenly or is not capable to speak. So what this band will do, the healthcare professional, based on this emergency bracelet, in the bracelet, the user will already give the permission to access these data, and healthcare professionals that just take the band and see the data and also trace the previous medical records of the patient. So this is one of the example where the blockchain technology used in healthcare data management. So now coming to the next part, blockchain technology in trade finance. Before going into that, we'll see what is trade all about. Please free to interact and tell us what you understand from trade, just the word trade.
Buying and selling.
It's exchange
Uh,
between a buyer and seller.
Okay.
Exchange of goods and services.
All are correct answers. So it is exchange of goods as well as services for a payment. It can be a domestic trade or international trade. There are many parties like buyer, seller, shipping company, government, and customs are involved in the trade. So why it is not only goods but also services? Because services is also a trade where you can do domestic services and international services. One classic example is as Venzo. Venzo is doing services for Showcom, which is international service, and also for Sama, which is a domestic service. So this is general understanding of trade. So now what is trade finance? So since it involves a trade exchange of goods and services between many parties, and also it can be domestic and international. If it is international, it is a cross border where you don't know who is the actual buyer or who is the actual seller. There is a lot of risk involved in the trade, like financial risk where for the goods you purchased. There is also a commercial risk. There is also a contract risk. There is also a country risk. For example, if it is international trade, and you have given some trade from goods or services to a country where there is a high economical risk, or there is a bankruptcy going to declare in the country. So all those risks are involved in the trade. So to mitigate this risk, banks are involved. Remember, the banks only help to reduce the risk, but not completely eliminate it. So there are many products and services offered by banks for trade. So those products and services are called trade finance. For example, documentary collections. The documentary collections is where a bank is involved to collect the documents from buyer and send it seller and give it to the buyer. Like it is just an upgrade to documentary collection where the bank is obliged to pay if the clean documents are presented as per the terms and conditions of letter of credit, and guarantees where the bank will guarantee if something is not happened or something is not finished within a date, we will give you the payment. And also some loans, finance, pre-shipment finance, invoice finance, post-shipment finance. All these services are provided by banks, and these services and products are called trade finance services. So now we will see what are the potential of blockchain technology to transform the trade finance. Streamline documentation. The first one is streamline documentation. The real problem here is trade finance process always involves multiple of documents leading to delay, errors, and inefficiencies. There is one application in blockchain technology called smart contracts, where there is a predefined terms and conditions, and once it is met, the process will be all automatic based on the smart contracts. So this will streamline the creation, verification, and execution of trade documents. The next one is supply chain visibility. The problem here is there is a lack of transparency in the supply chain, which can also lead to delays, disputes, and increase costs. So here the blockchain can provide transparent and traceable data to supply chain, and it is reducing the fraud and risk. It's like I mentioned earlier, the trade finance, it will reduce only the risk and fraud, but it will not completely eliminate it. So there can be double financing or manipulation of documents. It's all possible in trade finance processes. So here the blockchain will provide more security because it is decentralized and tamper resistant, and it also help prevents fraud by ensuring that once a transaction is recorded, it becomes immutable, or it cannot be altered that easily. The next one is real-time transaction monitoring. There is a lack of real-time visibility to see the status of the transaction, which can lead to delays and uncertainties. The buyer cannot see the status, what is the status of the transaction. The banks cannot see if the payment is already made by the correspondent bank. There is a lack of real-time transaction monitoring. So here the blockchain provides a shared and real-time ledger, distributed ledger that all parties can access. This allows for instance, verification of transactions, reducing the time required for approvals and minimizing the delays in trade finance processes. And the next one is cross-border payments. We have discussed a couple of times the cross-border payments, where the intermediary bank fees for different time zones issues all can be reduced using blockchain, and a speed payment can be processed. And next one is auditability and compliance. So meeting the regulatory and compliance requirements in trade finance can be very challenging. If you're a regular follower of trade finance, you will see the news very often that a lot of banks pay a tick penalty or fine for compliance breach. So this blockchain technology provides a transparent or auditable trail of transaction, which can simply simplify the compliance process and meet the requirements of compliance. And it is also easily auditable because you can trace all the compliance terms and conditions in the blockchain. So this is how the blockchain technology has the potential to transform the trade finance. Now we will see some one of the real world implementation of blockchain technology in trade finance process. In Australia, it can take up to 31 days to obtain a paper bank guarantee, because around 11,500 retailers in Australia and New Zealand rely on paper guarantees that are created through manual workflow. This makes the issuing a guarantee a tedious back and forth process. There is a transformation solution backed by Ligon 1B, a company called Ligon 1B, a fintech consortium. The consortium involves ANC Bank, Westpac, Commonwealth Bank, and IBM Australia. They developed a application called Ligon Arc. It is a blockchain platform that manages the end-to-end guarantee process with speed, security, and transparency. Platform features a digital workflow, standardized terms, and the security to resist fraud. With all the function in one place and immutable data transparent to all parties. The platform makes the issuance guarantee very easier to do the business. After implementing the pilot, after implementing the Lygon ALK with the actual customer data, the speed of issuing a guarantee paper is exceptional. It reduced from 31 days to 1 day, and in some cases it is even less than 1 day. It is almost like 90 to 95% improvement the turnaround time. So it is quite astonishing how blockchain technology can impact the trade finance processes, right? So I'll show you a quote which is said by Patrick M. Bryan, CEO of Overstock.com. This is Overstock.com. Now it is Bed Bath and Beyond, which is the first major retailer to accept the Bitcoin as payment in 2014. It is an e-commerce retail company which started by selling the surplus items and returned items in the e-commerce. So you have mentioned you're going to start seeing open source self-executing contracts gradually improve over time. What the internet did to publishing, blockchain will do to about 160 different industries. So it's crazy. With this, I complete my session. Thank you, everyone.